Hi. So today, so in the last week, we talked about how to create data frames if we are starting from scratch. And what we did was basically create vectors, different vectors, and these vectors are then combined together using a function called data.frame. And using that, we created them in the form of tables, or what is technically known in our language is data frames. So before going to, today the main portion which we will be covering for the rest of the session is like how to subset data sets, and also how to look into the different attributes and certain manipulations and operations we can do with respect to the data frames. So those are some of the things we will be visiting. If any point of time, it could become, I will try to make it as simple as possible so that everyone is with us, but at any point it sounds too technical or it doesn't make sense, I really appreciate if somebody can actually ask a question, or basically just even ask to go through again through the material, and I'm more than happy to do that. So before going into subsetting and all, so I will go and revisit what we learned about data frames and what are the different options of subsetting and some other things, so that it makes sense when we actually start executing the code. So I'll use pen and paper. So typically, let's say a data frame looks like something like this, right? That's what we look at. So a data frame is in the form of a table. We have columns, and each of the column is a vector of a type, and they have the column names. So these are three different column names: cat2, category2, and like for data frames, there are certain properties associated with it called something like dim, or you can say method associated with it called dim. And dim is nothing but to provide you dimensions of the table. So if you said, let's say we create this table and assign it to a variable x, and we said dim of x is going to give us the dimensions, which basically means number of rows versus number of columns. So the output of this one will be rows separated by space and number of columns. That's what it's going to give out. So this is one of the functions that is associated, or methods that are associated with the data frame. We can also do n row, which is going to tell us number of rows of x. You can say n col for number of columns of x. And if you want to get what are the column names, we can simply say col names of x. And similarly, like column names, there are also called row names. In this table right now, what we have up over here doesn't have any row names associated with it, but we'll see we'll look into how to assign row names to a particular data frame. What else? Basically, these are some of the functions we will look into it. There are other things. The one thing which we'll be visiting today is about subsetting the data frame. So when we start subsetting the data frame, basically what I mean by is sometimes you don't want to have an entire data frame for the subsequent analysis. You want to subset by picking or making the data set smaller by based on certain criteria or so. So in that case, you want to subset it. Sometimes you want to pick up only one column, and that's possibly going to be very common. So in that case, how to pick up a particular column? The column you can get is in the form of a data frame, or could be you can subset it in the form of a vectors. Both are possible. These are vectors, but when the columns are vector, but since the part of the data frame, they are actually is the part of the data frame. A column is a part of the data frame. So let's look at certain kinds of subsetting that is generally done in R. So one of the subsetting is X followed by square brackets. And generally, what you would see is if X with a square bracket and the number is inside there with no commas on either side, that basically means this is the column we are picking up. So that particular column will be subset. So for example, here, if you want to subset column number 1, this will become X1. So we are subsetting the column 1, and the output of that one will be a data frame with only one single column. We may sometimes have would like to subset more than, like, for example, the first and the third one, that is also possible. And that one is generally done as X square bracket. And the columns you're going to pick up, or we like to pick up, we provide in the form of a vector. So we'll say first column, third column. So this is a vector as an input, but what we're trying to do is subset it. So we're going to, the output will be this column and this column, avoiding the second column in the output. Okay, these are some of those ones. The other way of subsetting these ones is, which will come as very common, is basically R comma C. I'm just, so basically X subset the rows you would like to have and the columns you would like to have. You can have a one row and you could have like one column, then one specific value would be picked up. So for example, here, if we say 2 comma 3, it basically means pick up the second row and the third column. So this is the second row and the third column, and the output would be F. Right. Sometimes it could be, and you will mostly encounter something like this. Let's say comma 3. So if nowhere, so ideally the first value should have been row, but there's nothing there. So what it means is, you would like to take all the rows. A missing value of a row basically means all the rows, but the third column. So in that case, all the rows and third column, essentially you're just picking up only the last column. And the output of this one would be a data frame. Yeah, and the other way, you possibly would also see something like this, which would like X 2 comma no value of column. So in that case, all the column such has to be included, and but you would like to have second row. So in that case, you are picking up only this particular row, right? So this will be essentially row number 2. If you would like to pick up, you can also pick up columns by name. If you don't know the numbers, but you know the column names, the columns can be also, or the data frame can also be subset based on the column names. So the way it is done is X, and then inside it, you can have the column name, let's say cat, like this. Then we are specifically picking up the cat column. Or we can also this, another example is, if you have multiple columns you want to pick up, we can say cat, comma 2. So we are picking up the first and the second column in that particular case. And then the closing square brackets. So we are providing a vector again inside, but this time the vector is having the column names over there. So you can pick up the columns based on the names as well. If you want to pick up a particular column by just, you can say as a vector, you can use double square brackets. That's one of the ways. So the output of this one would be a vector. So you will say X1 is going to pick up the first column and then essentially convert it into a vector. Okay. Other ways to get vector is using this $sign. So X dollar, and then essentially tell us, okay, which, but if you're using dollar, then you have to use the column names. So if you are using here, then essentially if you're trying to pick up a cat, then we'll say X dollar cat. That's the column we are picking up. This will has the same output as X dollar cat in quotes. Now, quotes possibly most of the time we won't end up using if we have a good column name. But if our column name is a digit, like here 2, X dollar 2 will give an error. This is not pretty much not acceptable. So in order to get a column whose whose name is a number, that's where we will use the quotes, and that would be acceptable. And that's how we'll get the columns. All right. Now, one important thing which is most likely we will be doing, or you would be doing when you start analyzing your own data sets, is subsetting the data based on certain criteria. Okay, possibly let's say you in a big, huge data set, clinical data set, you would like to pick up all the male, all the you can say observations that are corresponding to males, but the whole data set is having males and females. So how are you going to subset it? So that's the kind of subsetting you would be doing. And for example, you may have a clinical data set with blood pressures, and you would like to pick up all the observations or all the rows in which the blood pressure is either within certain limits or above certain limit or below certain limits. So those kind of subsettings are very, very common. Okay. So one of the ways to basically, let's say we want to subset this data frame and we want to only pick up, let's say the column row 2. So we can say, okay, do we want row 1? No. So we can say, okay, the first one we don't want. So let's say it's a false. We'll say that this one we want, it's a true. And this one we don't want. So we are going to say false. All right. And to pick up the same way, and this can be subsetting can be done as okay, hopefully if anytime I go outside the screen at writing, just let me know. So x, by using a logical vector, we can subset like this, x, and we are picking up the rows, so we will put comma, and our observations has to be before the comma. So we're going to provide a vector of true. Oh, sorry, false. Sorry, the first row is false. We're not picking up the first row. True and false. Closing of this one, putting the commas, so telling us that these are the rows. The first row we don't want, second row we want, third row we don't want, but we want all the columns, and we close the square bracket. So this is pretty much in the format what we talked about here. Okay, x, no, not this one. Sorry, where is that one? We're only having, okay, this one, this particular format, which are actually looking only for rows. So we have values before the comma. So we want all the row, these particular rows, and the rows will be chosen based on false or true. If it is true, that row is picked up. If it is false, that is dropped off. So essentially, the output of this one would be this particular row over here. Okay. Right? Hopefully this makes sense. Now, how to get this logical vector? This is a small table we are thinking about, like 3 by 3 is not really a big table. But if you think about something about 10,000 rows, we can't essentially create a vector something like this, right? This is just not possible to write true, false, true, false, true, false, and then go through each row and try to figure it out. Okay, this is the row I want or I don't want. So we will create this logical vector based on certain criteria. Why would we like to? So first question is why we would like to have this particular row. So maybe we have whatever the column 2 holds, we want any of the columns whose value in column 2 is equals to 2. Let's say that's our criteria of subsetting it. So how will we do that? So let's first subset only the column 2 as a vector. So the only column 2 as a vector, what we can say, $2. This will give us this, the output of this one would be a vector which is 1, 2, 1, right? So I think this should be, we are just subsetting this column in 1, 2, 1. Okay. Now let's add a logical test to it. Okay. The logical test to this one is, so let's say forget about, or basically let's say the output of this one is assigned to y. So y holds this particular vector. Let's try a logical vector. Is y equals to 2? Sorry, it's not saying. Okay, is y equals to 2? This is a logical test we are doing. Or something similar we can do is, y is nothing but this one. So we can also say whether $2, which is nothing but this y vector, is equals to 2. And what it happens is the test is performed over all the elements. And the output of this one would be, when the test is performed, is x is the core value is equals to 2. So the output would be false, comma true, comma false. Okay. So we created this vector by using this logical test over here. This I have written just to explain like what we are doing, but we did this logical test that in the vector $2 is the values equals to 2, false, true, and false. Now let's go back and use this subsetting method of true, false. So instead of putting this one vector over here, what we can do is put the expression, this expression over here. So that expression would be, basically we are picking up the column. So this is the column we are picking up. So we're going to put the comma first. No, we are selecting the rows. Sorry, we are selecting the rows. So we in the place of the rows, we will say which rows we want to pick up. So we would say x $2 equals 2 and put comma and just close it. Essentially, the output of this one would be a test, output of this one would be a vector, something like this. And that vector will be substituted here, which will become something like this, equivalent to this one. And based on that, that particular column will be selected. So that's how we will use true and false. And you can perform logical tests to pick up subset a column based on certain observations, let's say we are interested into, or we are more keen in looking into. Okay. Any questions here? Basically, this is really important to understand what's going on in here. Please feel free to ask. I would be more than happy to explain, because this is really the basics of everything that we would be doing, or you would be doing if you're doing your own analysis. So need to have a really good, thorough understanding of this logical vector-based subsetting. If everything is clear, that's great. Okay. So now let's go to our console, and I will be going to the. Sorry, go ahead.
I just wanted to say that it's not that it's not clear. I think it just takes a little time to kind of set in.
Okay. Yeah. So yeah, you just have to possibly revisit the information and trying to. So how do we eliminate false and can generate new data set? Amit, did what I explained was okay, or you still there's something missing conceptually?
Those things are like, okay, I understand them, but like the only query to me is like, if you don't want certain rows with certain criteria and want to eliminate that, I mean, when it turns to vector, it's like true and false, but how do we make a new data frame out of that?
So basically, when you run this code, right?
Yeah.
This code, the output of this code will be a new data frame with having only the columns which are, or only the rows which are true.
Okay, I got it.
Okay, the output of this one, sorry, if I didn't mention the output of this one, because that's what we are doing, right? Subsetting the data frame using this way, actually this way, rows. So here we are just telling, okay, which all rows do we want? And the output of that one will be another data frame with same column names and row names, whatever the corresponding row name is. And those rows will only be there.
And then multiple, so now we are putting like 2, but multiple options can be added.
Yes, yes. We'll talk about and or kind of multiple operators, like you can have multiple logical tests being set up.
Yeah, and those are going to come, or like you already spoken about them?
No, that's going to be in the subsequent. We haven't talked about it yet.
Okay, got it. Yeah, thank you so much.
Oh, cheers. Okay, so thanks for asking that. Sometimes I basically don't realize that I haven't mentioned some of the concepts. So if you ask, that would be great. All right, so last week we talked about creating data frames using these up to the, I think, line number 30, or the code line number 30. So I'm just going to quickly run through this code because that is going to be used subsequently. So there's nothing. I'm creating 4 different vectors and then using data frame command to compile them as a data frame. Yeah, so that's a data frame. And these are the other ways we could have created them. So in this case, what is there that chip in subsequent all the code, chip2 is mentioned, but I haven't created chip2 anywhere. So this is the new code line that I added. So you can add exactly the same, which says chip2, we are basically cloning the chip vector, the first the chip data frame, the first data frame. We are cloning and naming it as chip2. Essentially, we're creating we're giving another name to, or basically chip2 has the same data as chip. Okay, so that's the line which is missing. So if you can add that one, that would be great. Okay, so I'm going to execute line number 32, and that's where okay, this didn't work. Why didn't it work? Is there no, this should work. Oh, right. Okay, no, I executed wrong line. Okay, this is fine. Yeah. So this is the code which I've executed down over here. And the rest of the analysis is pretty much around chip2 data set. So it's good. You need to have that line of code over there. Okay, I'm going to clean up my screen, which is Control L. And I'm going to, let's have a look at what chip2 data frame looks like before we start subsetting and playing with it. So this has this particular have column names X, Y, P, and E, and the row names are 1 to 10. Okay. So the first command is end row, which is a number of rows. So if you say end row, it's going to tell us number of rows is 10. Yeah, that's, we know that there are 10 rows. And call will give us number of columns. Those are 4. And if you use the dim function or dim method, it is going to give us the dimensions. So dimensions are always row first and column second. And the same thing holds when we are subsetting in the square brackets. We always mention row first, comma, followed by the columns. Okay, names is pretty much similar to call names or column names. So if you say names, chip2 is going to tell you X, Y, P, and E. The same column names can also be retrieved by function called call names. Column names, short is call names, and you say call names within the parentheses, you specify the data frame looking to pick the column names from. So it's going to from chip2, this is X, Y, P, and E. The next one is row names, as I think self-explanatory. So earlier we picked up column names, now we're picking up the row names. So the row names are here like 1 to 10. These, when we're creating a data frame and we don't specify row names, R tend to give numerical values based on the number of rows. So it's start counting from 1 and goes to the number of rows, and each have a one basically number value. But these row names can be changed, and we'll see an example like how we assign a row name. Okay. So let's and the basically chip2. So when we look at the row names chip2, the output was actually these values over here, right? So these are the right now row names chip2. These are the row names. What we want to do is we want to overwrite those chip2 existing names with new names. Okay. And that's what essentially we're doing in this particular line of code. So I will just copy and paste it and explain what we're doing here. So all right, okay. So row names chip2, basically this part of the line code will give us 1, 2, 3, or tell us what the row names right now existing. But when you use the reassigning arrow, what it does, it means that you're trying to overwriting the existing row names with these values. And the new row names, what we are providing has to be in the form of a vector. So what we are providing is a vector of 10 genes or gene names. And these gene names are possibly more meaningful to us. And let's see what happens. And now if you look at chip2, essentially you have a new column which is with the basically the row names has been changed with the row names which we have specified using this vector over here, right? If for some reason, let's say we want even if we want the same names in the column X as well, because gene 1, gene 2, gene 10 doesn't really make any like doesn't give an intuitive information about what the genes are. So let's replace those ones also by these gene names. We can do that as well. So let's do this one. So what we do, the way to actually replace values. So we are going to replace the values of from gene 1 to gene 10 by these new values. So this is what we're going to do. We're going to overwrite it. So going to overwrite what? The existing values of column X. So how we are going to do that? So let's say chip2. How to subset only the data frame, only the first column of the data frame. We can do this way. So chip2 1, as I mentioned when I was talking about, if you specify only one value, it always means that we are talking about the column. So here we're talking about the first column, that is this one. And then what we do is use the reassigning arrow, and we are reassigning new values. So the old values will be overwritten by these values. I'm just copy pasting from there and putting it here. So this is the new vector. So what we are doing here is we are, with the values which are already existing in column 1, we are rewriting or overwriting with this information of that is within provided in this vector. So let's see. And now if we look at chip2, you will see that the X column has been replaced from gene 1, gene 2, gene 3 to some more meaningful, you can say, gene names over there. All right. Any other question? Anything which doesn't make sense here, please let me know. Okay. So I'm going to clean the screen. This is too much over there. So I'm going to redo chip 2. That's what it is. I'm just creating another copy of here, which I really don't understand. I don't know. Maybe I'm using there later on. So let's create this one. So this is pretty much like making another copy of chip 2 in the form of chip RN. So that's okay. Now, okay, again, we are looking in the row names of chip 2. So there are no new row names of chip 2. If you want to remove any of those row names, you can assign that to null. So anytime, for some reason, if you want to remove those row names, you can use this particular chip overwriting with null. Null is like lack of anything, no data whatsoever. And if you now look at chip 2 over here, chip 2 has been replaced. So the old, whatever the row names were there, those row names has been removed because we have replaced those one with by null. Null is nothing but lack of any kind of data or information. So R cannot have a data frame without row names. So since we have deleted the row names, R gives by itself the 1 to 10, whatever the numbers that are there. All right. So occasionally it will so happen that when you're trying to play with the data set, you will import a data frame, something like this, and your row names or basically the column you want to have as row names is part of your data set. So let's say if we want to use the values in column X as our row names, we want the same names as instead of 1 to 10. So this is the most typical, I would say, kind of operation you would see when you import a CSV file or a text file from your own data, and you want to create, basically assign some row names, and the row names are nothing but part of one of the columns. Yes.
What? You want to Zoom?
Okay. Can you mute your microphone, please? Thank you. All right. Okay. So one of the columns, column X, has values, and we want to use them as the row names. Okay. And now, so we are going to do two operations. The first operation is we are going to first see what the row names are, existing row names, and then overwrite by a vector of the row names we want. Okay. We are going to collect the row, we will collect the row names, existing row names, and overwrite by the row names we want in the form of a vector. Okay, so just follow this one. So what are the we are exactly going to use the same what we have used before. Okay, I have cleaned the screen, but the way we use this function to write row names, we are going to do exactly the same. So we are first find out what are the row names are, or basically create row names. Chip 2. So those are the row names from 1 to 10, right now existing ones. What we're doing is we're going to be overwriting with the information which is in there in column X. And this one we want in the most likely, it's good that we are going to provide that one in the form of a vector. So what essentially we're doing, we're subsetting this data frame. And in the subsetting, we are only subsetting column X, and we want column X in the form of a vector. So what we can do, chip 2, then the most common way of creating a vector is $sign. The moment you type dollar, it will already prompt you, okay, which column do you want? So you can use your arrow keys to go up and down, or cursor keys. And whichever you select, either you press tab or hit return, it will pick up that particular column. So now what we are doing is this part is subsetting this data frame and subsetting, basically subsetting X out of this data frame. And because we are using $sign, the output is in the form of a vector. And that vector is used to assign row names or overwrite the existing row names. So let's see what happens. Now, we used one of the columns to create the row names over here. And this is very common. This is very, very common you will come across when you're doing your own analysis. Okay. The next part we are going to do is assigning column names. So we assigned now row names. So similarly, we can assign column names. So the column names here is X, Y, P, and E, possibly whatever they mean. they're not really very intuitive. So let's replace those names with more meaningful ones. That's the code on line number 56 we are talking about. So the way we are overwriting the existing row names, we will be doing overwriting the existing column names. So what are the existing column names? Column names, chip2. If we run that particular code, it's going to give us the column names. So what we're going to do is overwrite this. So I'm using my arrow keys to get previous command or from history. So if you use your up and down keys, you can go to the previous commands we have typed or you have typed. Now, what we are going to overwrite it, we are going to overwrite with new column headings or column names. And that also has to be in the form of a vector. And we provide gene ID. And those are the things which we think is more meaningful. And we hit return. Now let's see what how our data frame looks like. Now it looks much better. Now we have proper column names and we have proper row names. So we have like pretty much like refined our table right now. Any questions here so far? Sorry? Any column? Not any column, any questions? All right. So if no, then I'm going to clear up the screen just so that, oh, no, not clear, Control L, and I'm going to just say check 2. So that's what we have got. We have renamed our columns, we renamed our rows, and it's sort of like a clean data set. Okay, so let's do some more operations on this. One of the very common, the way to find out what the object you have is the class function is still executable on data frame. So if we say class chip2, it's going to return that it is the data frame. Okay. The next thing is two commands, head and tail. More again, if you are doing analysis of your data, this is the command again you will be using many number of times.
Vijay,
Yeah.
can I question?
Sure, please go ahead.
In the code in console, line number 47, why did we assign chip2 to another variable? I couldn't see any function of it.
So I don't know, maybe I'm going to use it later. I have no idea. Oh, we are going to use it later some point of time.
Oh, okay.
So I have created basically, if you do chip_rn is nothing but chip2. So there are two now.
Yeah.
Chip_rn and chip2 are two data frames that are existing here. So I just created at that point of time. That's what I said when I executed that line. The idea was just to, because we will be using that object chip_rn later on in the analysis. So that's wait. Okay, but that's the only purpose, nothing more today.
Great, thanks.
No worries. So the other two functions we will be most likely going to use when you're having large data sets is using head and tail functions or tail methods, head and tail methods. And what they do is they give you a really brief view in sense the first six and rows or the last 6 rows of your data frame. In this case, the data frame is 10 rows, like 10 rows. It's okay, we don't need to, but in most of the cases, when you're importing your data, would have thousands and sometimes millions of rows. It's literally not possible to see what's the outline of or you just want to have a quick peek to see what the format of the data is, what are the column names are. The easiest way to do it is basically to use the command head, and within the parentheses, you provide the data frame. So here we can say chip2. What it does, it returns back the first 6 rows of the data frame. So these are first. If for some reason you want to see less or more, so let's say this is taking too much space. I just want to only see 2 rows. So you can say chip2, 2. Basically, you want to see only 2 rows. So that the next value is pretty much how many rows you want to see. You can change it to 9, then it's going to show you 9 rows. If you do 2, it's going to show only you 2 rows. And this displays only the 2 rows. And this, the head and tail is more or less the commands. If you have ever used in Linux, they also have a head and tail command, but the syntax, the way you write it is a little bit different. Now let's look at the tail of chip2, and same last 6 rows. Now from bottom it counts 6, and those 6 are displayed. It still retains the column names, so which is great, and the row names as well. And the same operation is you can say permissible. You can define how many rows you would like to see from bottom 3. Just 3 of those one would be seen. Thank you. right? There's another command which says view. Generally don't use a lot, but what you can do is if you want to visualize the whole data frame in the form of a table, you can use view with a capital V, view, and in the parentheses you provide the data frame you want to see in the form of a table. And it looks like it will be the output, what it will be displayed, it is in the form of an Excel sheet kind or a CSV file, CSV sheet kind of thing. And it won't be displayed here. It opens on the console side. Okay. So let's execute this one. And what I mean is now you see in a much more formatted way, the same information, rather have very neat, you can say, cell of each position and that information. Okay. So let me go back to that. Okay, here. So that's the view command is. So if anytime you want to see it, you can do this way. That's the one way, typing view, or the other way is, let me go in environment. So if you see here in my environment, all these variables which we are creating are being listed here. You can simply click on chip2 and it will open in the form of edited here. You can see any of those ones. So what they actually contain. So that's a chip3. A little bit different than those ones. So any table which you have created, you can have a look in the form of a, if it is a data frame or a matrix, you can see something similar. Or if you are, anytime you click on here, you can see that the command is getting executed on the console and the command is view. Okay, now, okay, so we did pretty much like head and tail, column names, row names. Now we are going to do the subsetting of columns and other information. So let's have a look at that one. I'm going to clear my screen, Control L, and let's go. The first subsetting is. So if you, the first one is at line number 77, and what we're doing is providing the data frame, square brackets on only one value. And as I mentioned before, if you have only one value, the output is going to be only one column. The output is in the form of a data frame. So let's execute that line, Control Enter, and that executed. And you can see it picks up the second column of chip2. So let's see what the chip2 looks like. That should have been on the top. So yeah, it picked up the second column, and thus you're picking up only one of those ones. The next one is using the $sign. So the $sign essentially returns a vector. Okay, so it's, the column we are selecting is chromosome. So you can see that it is actually picked up CHR1, 2, 3, and 4. Okay. We can also pick up now. The next one is using again square brackets, but this time we are using comma. So a comma basically means we have to provide some value for rows and some value for columns. In this particular case, we are not, the column space is empty, essentially means we want all the columns, and the row name has value 2. So we want second row, but all the columns. So that basically first row, second row, and all the columns. So this should be our output. So let's have a look at it. Chip2, square bracket 2, comma, and that is that particular row. It actually gives an output. Now the code, okay, here, 85, we are specifying a range of rows. So 1 colon 5 basically means a vector of column number 1, 2, 3, 4, and 5. And in the column names, we have 2 colon 4, which is again a vector of column names 2, column numbers 2, 3, and 4. So essentially, this can also be, this is equivalent to writing the whole thing as chip2 square bracket. And first, let's put a comma. And first, we specify row values. We are using multiple ones, so we are going to have we have to provide in a vector. So vector is created by C and putting parentheses. So which all column we want? 1, 2, 3, 4, 5. And which then we are going to specify rows, since we are selecting more. So these are the rows actually. Sorry, the first one we specify were rows. Now we are going to specify columns, and column is again since we are providing multiple columns, we have to provide in the form of a vector, and we are using the vector notation, which is C and parentheses, and the columns we want are 2, 3, 4. So this and this are exactly the same thing. This is a shorter version of writing it. Okay. This output this, And this is also going to output exactly the same information. Now, we're going to subset now again using comma, but this time we have very precise values. So we have third row and fourth column. So you can see the first, second, third row. This is the row, and the fourth column, first, second, third, and fourth column, the value is 3.50. So there's only one value corresponding to it. So let's see what it gives. And thus it gives 3.5, because it gives the third column, third row, sorry, and the fourth column, which is 3.50. We can also pick up columns by specifying column names, but if you're picking up more than one column name, it's always provided in the form of a vector. And since the notation of creation of a vector is using C and parentheses, so we use C and parentheses, and we use CHR and ENR. Those are the two columns we want. There's nothing before comma. That basically means we want all the rows. But the columns are CHR column, or the chromosome column, and the enrichment columns. Let's do that. And it picks up only CHR and the enrichment column, because we have specified. So you can specify numbers. Numbers are nothing but the index values. Okay. Each call, as we know that values in vector have indexes, like first, whatever the first element has value index 1, and then the second element is 2, and so on and so forth. Similarly, these columns also have indexes like 1, 2, 3, and 4, and the rows also have indexes like 1, 2, 3, 4. And based on that, we are using those index values to actually subset these data frames. Okay. So here in this one, we are subsetting all the columns, not all the columns. What we are subsetting is 3 rows, 1, 2, and 3, and only one column. Now, this is a little bit a very, very bizarre behavior. Not, I won't say the bizarre, but this is something where R has a syntax which looks really odd and out of place. And I will explain how and why. Okay. So let me clear up the screen. Look at the chip2 object. This is our chip2 object. And before this, whatever we have, like, for example, when you're selecting objects like this, everything what we are getting is in the form of a data frame. In R, what happens if you use multiple rows, only one column? If you subset using multiple rows and only one column, using square brackets and comma, the output actually tends to be thrown out as a vector. So let's look at this one. So chip2, multiple rows, 1, 2, 3 rows on only one column, and the column is number 2, which is this one over here, chromosome column. And the output you see is more in the form of a vector. So this is where you have to be little remember it, that when you subset like this, R tend to drop the dimensions in sense it drops its rows and column values, and once it drops the rows and column values, it becomes a vector. This is a little bit a technical thing, but I would appreciate, there's no explanation I can give around it. But essentially, if you're using multiple rows and picking up only one column, those values will be returned as a vector. The only way to retain it still into the form of a, let's say we don't want to convert into a vector, then what general people do is drop equals to false, which basically means don't drop the dimensions, and output what you get is in the form of a data frame. This is essentially explaining the same thing for that. Okay. Next thing, okay, right. So one of the things I want to go over is, okay, let's finish this one and then we'll come back on that one. Okay. Clean this one up, and let's have a chip2 again on our screen. So we have reference. So we see this one. We can also find out which are the rows which are having NA. Okay, if any of the rows or any basically any of the column has an NA value, you can either get that particular row or you can get data sets removing that particular row. So those are the two different things. So you can either get only this row to see, okay, which all rows are having NA, or you don't care if there is an NA, you don't want to pursue further. Maybe the kind of analysis you are doing, this enrichment column is really key. If there is no value in that one, you don't want to pursue it further. So you want to remove this particular row out of your data frame, right? So there are two things to do. One is look specifically which row has NA. Another is to get a data set without NAs, okay? So before going that, I will revisit one of the things what we did previously is creating a vector. So let's say, let me create a vector X. And in this case, I'm going to create a vector of 1, 2, 3, 4, 5, and comma NA, comma 7, 8, 9, 10. Okay. This is a vector. And in this vector, there's one NA inside it. Now, what is the way to know if there is an NA, which of the elements is an NA? So what we can do a logical test. And the logical test is dot NA, and we do it on X. So we're going to text whether the value in NA is, if the value in X is NA. And this is applied on each element. It tests each element whether it's an NA or not. And the output of this is going to be false, 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 and this NA, it gives you true value, remaining false, 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 false. Okay, hopefully this makes sense. Now the reverse of this is also true, which are not NA. So let's say if I want to say this code is giving out as which is NA. Now we want to say, okay, which is not NA. So if you put an exclamation mark, it negates the operation, which basically means it's going to do the other way around. And now it's going to, if the exclamation mark is an dot NA, essentially reads which is not an NA. And this time the output is, this is not an NA, so it's true, not NA, not NA. So all the not NAs are true. When you see an NA, it is false because it is an NA, it's not an NA, basically, yeah. Hopefully it explains, okay. So these are the two outputs of these ones, okay. So let's pick up one of the columns in our data frame up where we are really interested into and may want to use for downstream analysis is the enrichment column. And the first thing we want to test is whether it has an NA inside it. So we can run is.NA on a vector. So let's first write is.NA and we're going to run it on a vector. Now we want to pick up enrichment column in the form of a vector. So chip2, and to get it as a vector is the dollar. Dollar is the best one. So pick up this one, chip2 dollar enrichment. So that will present the enrichment column in the form of a vector, and is.NA test will be applied on it. So false. So none of these are NA except the last one. So that's where it is true. Okay. So based on this, if you are trying to fish out a column, we are fishing out rows from this table. We are fishing out only the ones which has an NA. Okay, so this should be false, 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 and this is true, false. So this is essentially present in this vector over here, which we got from here. So let's subset now chip2. And so I will start with putting comma. So we want all the columns, but in the rows, we don't want the rows in which chip enrichment is NA. And this is the way to test whether, or basically we want, sorry, we are only picking up the row first, which we are picking the rows which has NA. So this, this one is testing if there is an NA in enrichment column. So there's no NA until the ninth one, which is true. And the rest of them are false. So if you provide this false, 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 and true, false vector here, we essentially will pick up only one row, which is true, which is this one. So rather than writing this whole vector, why don't we simply write this expression whose output is a vector? So simply copy from there and paste here. Oh no, copied something wrong. Okay, and just simply putting it over there. And now let's hit return. And it picks up. That's the column which is NA. We haven't done nothing. We have done exactly the same way. what I was talking about here, like if you have false, true, false associated with each column, those column, wherever the column holds true, the value holds true, that columns will be picked up. Essentially, the true, false we are providing are these ones. In this one, only one of them is true, which is this one, and that's why it returned it to this one. Now, let's negate this one, okay? Negating this one, what I'm trying to say is, let's find out which all is not NA. So this is going to give us which all is NA. If you put an exclamation mark, it becomes which all is not NA. So so it tells you everything else which is not NA as true and an NA as false. Now, let's subset our data frame of such a way that we remove the NA rows and only have the clean where the values for enrichment exist. So we're going to do again the same way of chip2 dataset subsetting. Here you're going to use square brackets. We're going to subset using comma. So we're going to specify rows and columns. We are not going so comma, since we want all the columns, we want to remove the rows which have NA. So the selection we are providing, or the selection we are putting, is essentially in the rows. So we are going to specify values in the rows. Columns we are not selecting, so columns we want all columns. And the selection we are putting is the rows in which enrichment is not NA, which is basically this one. We copy from here and simply put it over here. And this one we can assign, let's say, for convenience sake, I'm going to chip 22. Assigning, I'm just assigning to another, the output I'm assigning to a new, you can say, variable, but the output would be, let's look at what is the output. So this is what, so you can see now the NA rows has been removed. So essentially this is the kind of most common data frame subsetting you would see when you are performing. And if you ever come across data wrangling or data munging, and so a lot of time in analysis is spent on cleaning your data sets. The analysis part, running models, creating model, testing model is really, you can say 20% of your time. 80% of your time I end up spending is cleaning a data frame. If you get an object or get some sort of a file from someone, if it is clean, that's awesome. Otherwise, most of the time we spend a lot of time to clean it up, to remove values, or sometimes the column type is not correct. So you expect numbers, but for some reason there is something is there which actually converted everything into character. You change all those things. Those all kind of operations you end up keep on doing. So data cleaning part is really a significant part of data analysis. I end up spending quite a lot of time doing that. And these kind of tricks are very handy to select certain, to find it out, okay, what's going on in the data set. Okay, any questions here for before we go ahead? Okay, if there's no questions, can I ask a small exercise for you people to do if you have been following along? To basically, you have to create this chip 22. And what I want as an exercise want you to do is to pick up the columns or pick up the rows whose enrichment is more than 2. Only the column, only the rows on which, or only the observations where enrichment value is more than 2. So I'll just give 5 minutes and then take your time. You can copy this code to create chip 2 to get rid of NA from there. You will need this clean data to perform any other operation. So clean this way and then subset it so that the enrichment values are more than 2 or 2.5, whatever cutoff you use, but just try some value 2 or 2.5. Let's say 2.5. Okay. So the question is subset chip 22 with enrichment score greater than 2.5. That's the oh, where did I type? Greater than 2.5. That's essentially it's a short exercise. And my suggestion again is right now, the way we are doing is basically control enter, then the line is getting executed. If you're learning it, that doesn't help. You have to literally, so my suggestion is type the code. Don't just control enter it, because there's some nitty-gritty details which you will observe when you start typing, you're missing, and you're basically unconsciously, we don't register many things. So it's better you type it, so you get a practice of writing it correctly or typing it correctly. And at the same time, try different ways of filtering it, try different column names, try really silly things. The best way to learn is actually do the things which you think is not possible, or it doesn't allow you to do, or basically ask question, can we do this? Can we do that? And that's where you learn more and more about it. So I'll stop talking and give you maybe a couple of minutes to think and do that. Okay, hopefully you've given some try here and there. Anybody needs more time, or should I show you how to do it? I mean, I just write the code how to do it, so you can follow along on that one. So if it has given you errors, don't worry about it. Means you have to go back and practice these things a little bit more, then you get fluent with these things. But yeah, giving a try is the beginning of it. The whole learning process here. So chip 22, we are trying to subset chip 22. And again, we are subsetting, we want all the columns. We are not subsetting the columns. So I'm going to put a comma. So put a comma over here, just trying to say that, okay, we can specify values, rows, and columns. We're not going to choose, we want all the columns. Only selection we are doing is on the rows. We want only the rows where the values are greater than 2.5. And 2.5 for what? So we simply put, oh, sorry, this was chip 22 actually. Sorry, not chip 2. Okay. Chip 22 $ENR is greater than 2.5. So wherever the chip ENR is greater than 2.5, those values will turn true. And if it is not, those values are going to, those particular places, it will turn false. And that's the way we are going to subset it. So if we run this one, oh, right, I did some mistake somewhere. What did I do? Oh, yeah, okay.
Rows to
The ENR, it's a capital E.
Yeah.
And you can see that now you can pick it up all the rows which has a value more than 2.5. So we are specifying the rows. We are only selecting the rows where the enrichment value is more than 2.5. So I will stop here because it's already 3 o'clock. So next week we will talk about merging tables. That's another crucial thing. In data analysis, you get tables and observations in 2 different tables. You want to merge them based on a primary ID, or you can say based on a row name. a column with unique IDs, you want to merge them to create one single data frame or table. That's what we look into next one. And also, if we existing data frame want to add one more column, we got some observations or some vector values, and we want to add one more column, how to add more column, and at the same time, how to add one more extra rows. So those are commands are like cbind, rbind, and merge. Those are 3 commands we will visit next week. But for now, basically, I'll stop and take any questions if you have.